The integral as an antiderivative, part 2. From part 1, we saw that the integral of f prime of x dx equals some function f of x plus a constant of integration c. What if we said that the integral of f prime of x dx is the integral of, say, x cubed minus a fourth dx, but we know more information about the original function f, where f of 1 equals 2. Here, we're going to find what we call a particular solution for our antiderivative. How does this work? Well, let's do the antiderivative of each of these pieces. Using the power rule for the first one, we get x to the fourth over 4, adding 1 to the power divided by the new power. For the second piece, you can think of this as being negative 1/4 times x to the 0 if you want to. So we get negative 1/4 x to the first over 1, or simply x, and plus c. And this is a general antiderivative f of x. But recall that we have more information. We know that when x equals 1, so 1 to the fourth over 4, minus 1/4 times 1 plus c equals 2. Solving for c, which equals 2, we see that f of x is x to the fourth over 4 minus 1/4 x plus 2. And this is what we call our particular solution to this antiderivative. Let's do some more examples just to get some practice. Let g of x equal the integral of 3/2 x to the 1/2 plus 2x dx, where g of 4 equals negative 1. What is the particular solution for g of x? We will find some antiderivatives. Constant rule says we can ignore the 3/2 for now. I'll leave a little space. And then we can integrate x to the 1/2. We'll add 1 to the power, x to the 3/2, and divide by 3/2. But instead of dividing by 3/2, let's multiply by the reciprocal, 2/3. Plus 2, and then add 1 to the power, divide by the new power. Or you simply know that the antiderivative of that one is x squared plus c. Cleaning g of x up just a little bit, we see that g of x is x to the 3/2 plus x squared plus c. Now we can use this piece of information, often called an initial condition, to find the particular solution. So when g is negative 1, I'll start by plugging in g first. I know that x is 4. So we get negative 1 equals 4 to the 3/2 plus 4 squared plus c. So negative 1 equals the square root of 4 cubed plus 4 squared plus c, which means that c equals negative 25. And our particular solution is g of x equals x to the 3/2 plus x squared minus 25. Let's do another example here. Suppose that h of x is the integral of e to the x plus sine of x plus cosine of x dx, where h of 0 equals, let's say, 3. How do we find the particular solution for h of x? Let's do our antiderivatives. We have to know that the derivative of e to the x is itself, so we can just go backwards like that. The derivative of what equals positive sine x? Be careful here. The derivative of negative cosine x equals positive sine x. The derivative of what equals cosine x? Well, the derivative of positive sine x equals positive cosine x. Remember, you have to go backwards. It's very common for students to mess up signs. They take derivatives when they should be doing antiderivatives. And then plus c. Plugging in our values, we get 3 for h equals e to the 0 minus cosine of 0 plus sine of 0 plus c. 3 equals 1 minus 1 plus 0 plus c. So c equals 3, and we get our particular solution, h equals e to the x minus cosine of x plus sine x plus